Page 59, product, quotient, and power rules for exponents. Let's take a look. Let's try to find these rules. 2 cubed times 2 squared. Well, that's 2 cubed, whoops, times 2 squared. Okay. So now I've got 3 2s times 2 more 2s. That's 5 2s multiplied all together. This is 2 to the 5th, which happens to be 32. X squared times x to the 4th is similar. We're going to take an x times an x. X times x times x times x. There's a dot. 6 x's all together. 2 here, 4 here. So if we have a number x, whether it's 2 or a variable or whatever, and integers a and b, we can just add the integers. Multiplication with the same base means I just add the, excuse me, I think I said integers, I meant exponents, which are integers, so I suppose I'm not wrong. X to the a plus b. So let's look at some examples. This is a to the 3 plus 2, or a to the 5th. I'll let you take a look at number 2. I'll give you the hint if you want it. Feel free to pause if you don't. Hint is let's look at the 5 and the 7, work on those, and then work on your a terms. We can move things around using the commutative property. Number 3 is similar, but we have some negative exponents and stuff. Let's do that one together. As always, feel free to pause if you want. What I notice is that I've got a 5 here and a 5 here. I'm going to move this 5 cubed. Then I've got a to the negative 3, a to the 6. Okay, 5 times 5 cubed. That's not 25 cubed because exponents happen first. So this is 5 cubed, 3 5s times 1 more 5. I could call it 5 to the 1st if I wanted. This is 5 to the 4th, a to the negative 3 plus 6, third. If we wanted to evaluate 5 to the 4th is 625. We can just do that on our calculator using the x to the y button or y to the x button. But we don't have to. We can just leave it like that unless you're asked for an exact answer. And take a look at this one. It's similar. Watch your minus sign. Don't forget that one. Okay, 5 squared to the 4th. Taking 5 squared. Let's actually write it out a little differently. So 5 squared, that's just 5 times 5. I want 4 of those. I have 4 groups of 2. It's multiplication. So when I have a power here, I'm just going to multiply. This is 5 to the 8th. Let's see if that holds here. A cubed squared, so I write it twice. 2 groups of 3. This is a to the 6th. So if I have a positive number x and integers a and b, x to the a, all raised to the b power, those parentheses are super important, is x to the ab. So we'll simplify. We have 6. This is outside the parentheses, so it doesn't get the squared, but the inside part does. So this is 6 times c to the 4th times c to the 4th, or 6c to the 8th. Here I have negative a times a squared to the 4th. So this is negative a. I'll start with this part right here, times a to the 8th, 2 times 4. What exponent is this to? Pause if you need. Yeah, we can always throw an exponent of 1 on there. So this is negative a to the 1st times a to the 8th. The negative sign just makes the number negative. It's not up in the exponent. So I have 1 plus 8. It's negative a to the 9th. I guess I did these out of order. Number 2 is a times a, because that's a squared. A times a times a times a times a. I need to write that 3 times. I'm not actually going to do it. Okay. So I have 2 A's, and then I have 3 groups, and each group should have 5. I got a little lazy at the end. So I have how many A's altogether? 3 groups of 5 is 15, plus the 2 makes 17. I'm using the power rule and then the product rule to combine a squared and a to the 15th. So this is one way to do it. There are other ways to show your work. Let's add one more example in. No, we'll get to that later. Okay. Quotient rule. I have 4 to the 5th power, so I have 5 of these 4s. I have 2 of them on bottom. I can divide top and bottom by the same number, right? So divide by 4, divide by 4, divide by 4, divide by, divide by 4. Okay, so I'm left with 3 4s, because that goes away too. So 4 to the 4 cubed. What's in the denominator? We divided by 4, we divided by 4. We're not left with 0, we're left with 1, the multiplicative identity, right? 4 divided by 4 is 1. So I could make this a fraction with a 1 in the denominator, or I could just call it 4 cubed. And again, we could evaluate if we wanted. Don't have to, but we get 64. X cubed over x to the 4th. 3 x's on top, 4 on the bottom. Divide by x top and bottom. We'll do 1 pair, 2 pairs, 3 pairs. I'm left with an x in the denominator. And what on top? Think about it. That multiplicative identity again, 1 over x. Or, if I prefer, I can think of that using the rule that we found on the previous page, I believe. I can think of that as x to the negative 1. Why is negative 1 so cool? Because negative 1 is 3 minus 4. So we can get this by subtracting. This is x to the a minus b. So there's our quotient rule. Okay. I'll leave number 1 for you to do. And if you're not sure how to do it, go ahead and take a look at the rest of these and then go back. Number 2, we have some constants, or some coefficients, I should say, and some variables. I like to kind of split this up. This is 12 halves times x to the 5th over x to the 11th. I'm allowed to do that. Okay, so let's simplify each piece. 12 over 2, well, that's just 6. X to the 5th over x to the 11th, that's x to the 5 minus 11, to the negative 6. Or, if I prefer, I still get my 6, and I can take 11 minus 5. 11 minus 5, so that's 6. What's on top? Just like up here, a 1. 6 times 1 over x to the 6th, that's the same as 6 over 1 times 1 over x to the 6th. So that is, put it right here, 6x over x to the 6th. So 6 over x to the 6th or 6x to the minus 6, those mean the same thing. Okay, number 3 is pretty similar. I might do something like this where I take this and split it into 3 parts. I've got 28 over negative 8. I have x to the 5th over x to the 15th. And I have y to the 9th over y to the 4th. I can either take 5 minus 15, take 9 minus 4. Got to divide those. So be careful, you don't want to subtract those. The 28 and the negative 8, in case you didn't see. So we can either just subtract and get negative numbers, kind of like we did here, or we can look at the largest exponent on each of these fractions. The largest blue exponent is 15, the largest red exponent is 9. So one way to do this, let's simplify negative 28 over negative 8. Divide top and bottom by 4, let's say. I have negative 7/2. X to the 15th, the bigger number is on bottom, so this should stay on the bottom. And that's x to the 15 minus 5, x to the 10th. And then y, the bigger one's on top, it stays on top. 9 minus 4 is 5. So I have negative 7y to the 5th over 2x to the 10th. If you prefer, you can write it with negative exponents. Actually, I want you to be able to do both. That would be negative 7/2. X is in the denominator, so we'd make that exponent negative. X to the negative 10. Y, that's in the numerator, so that stays positive. And that's just a weird little seven. Okay. So we have 2 ways to write this answer. Take a look at number 4. Notice that we have the power rule, the product rule, and the quotient rule in here. So you get to use every piece that we've done on this particular problem. I'll have you pause it and work through it, and I'll give you the answer, just so you can check your work, because there are a lot of steps. If you don't get this, go ahead and go back and check. But hopefully you're getting either a to the 9th over 8 or 1/8 a to the 9th. Those are equivalent answers. You only need to have one of those. I like to write it on the left, the way on the left most of the time, but sometimes the way on the right is handy as well. So that's the product, quotient, and power rules.